Welcome to this session where I'm going to tell you everything that's new for Azure Databricks and give you a sneak peek of what to expect coming soon in the near future. My name is Kyle Weller, and I'm a program manager on the Azure Databricks team at Microsoft. I hope that during this session, you feel inspired to share feedback and ask questions about our roadmap and direction. I hope you're excited. I know that I'm excited. Let's dive in. First, here's the agenda of the things that we're going to review today in this session. We're going to do an introduction of the product, make sure that everyone's on the same page. I'm going to share some exciting announcements with you, and then we're going to get into our roadmap. I'll cover everything that we've released recently that's new, and I'll talk about all the new exciting things that you have to look forward to as well. Then I'll throw out a couple of top questions that I've heard from many of you in the past as well. So diving in, if you are new here and you're wondering, what is all the buzz about one of the hottest products on Azure, let me give you a quick introduction. If you have data and lots of it, then Azure Databricks is going to be your best friend. It is a high performance, limitless scaling, big data processing and machine learning platform. Whether your goal is to extend into untapped sources, gain insights in real time, or perform advanced analytics, Azure Databricks has you covered. Azure Databricks is collaborative. You can create workspaces with advanced role-based access controls, create collaborative notebooks, and integrate deeply into CI/CD DevOps processes with your entire team. Azure Databricks is connected. This is a first-party Microsoft product that we have engineered native connections with almost all other Azure services in the Azure portfolio. Azure Databricks is fast. Really fast. We are going to spend a solid chunk of our time here today highlighting some of the new advanced innovation we have been pouring into the Databricks runtime. And of course, Azure Databricks is secure. With a wide variety of industry-leading compliance certifications, you can feel comfortable that our security has been scrutinized and vetted by third-party auditors to meet the highest standards. Let's take a look at what the recommended architecture patterns are for Azure Databricks on Azure today, just to make sure that we understand how it fits in with the rest. So first, you always start with a wide variety of data sources. You have data that's structured, you have data that's unstructured, you might even have data coming at you in real time, and you need to make sense of this data. So you're going to ingest this data into a central data lake on Azure. You might use tools such as Azure Data Factory, an amazing ingestion tool. Azure Data Factory is also a great pipeline and job orchestration tool that you can have end-to-end data pipeline orchestration. You can, if you are dealing with real-time data coming from IoT sensors or whatever it might be, you might want to leverage things like Azure Event Hubs, Azure IoT Hubs, Apache Kafka, various messaging buses, we like to call them. You're getting this data centralized on a data lake like Azure Data Lake Storage Gen 2 on Azure. From there, that's when Azure Databricks comes into the picture. Azure Databricks you're using to explore, to transform, to process this data, and to make use of it, to utilize this data. You are transforming and making real business impact with this data through Azure Databricks. So you can even use things like Azure Machine Learning or its integration with MLflow to train and score machine learning models. Then from there, depending on your business use cases and your scenarios that you're trying to accomplish, maybe you want to serve real-time line of business applications, and maybe you want to utilize a more operational database as well. So, because I mentioned Azure Databricks has native connections to all these other Azure services, you can have Azure Databricks send data to an operational database like Cosmos DB or SQL DB. Or if you're aiming to achieve enterprise BI solutions, you can connect with Azure Synapse Analytics, our next-gen data warehouse technology. We've engineered high-performance connectors here. You can even stream data into Azure Synapse Analytics, connect up to Power BI, and truly unlock large-scale concurrency data warehousing type scenarios. So now that everyone's caught up, I want to get into what's new. Here are a couple top callouts and I will have a more thorough list near the end of this session. So the first one to talk about, Databricks Runtime 7.x with Apache Spark 3.0 is now generally available. Wow, this thing is so jam-packed with features and has been highly anticipated by all of our customers. We'll talk about some of the key features in the next few slides, like adaptive query execution, dynamic partition pruning, and so many more game-changing breakthroughs. The next one on the list, our new Delta engine with Photon. I will spend the next few slides right after the Apache Spark 3.0 to show you how we have built off of Apache Spark 3.0 and enhanced Spark performance even further. Redash is a brand new experience we are releasing soon that will offer simplified and powerful SQL environments to help business analysts feel even more at home. Workspace 2.0. This is an exciting evolution in our advanced new feature set aimed to increase the productivity of data scientists. I will show you a few of these features in a few slides as well. And last but not least, I want to give a shout out to all of our potential federal customers out there. I know you're watching. We are in public preview on the Azure US Government Cloud, and we'll be hitting our GA release very soon. We have also received FedRAMP High certification for this offering already. This is a super rigorous certification, and we're very excited to share the news that we have received this already in the Azure US Government Cloud today. Okay, let's move on and double click into a couple of these top announcements. The first one here, Apache Spark 3.0. This is the next big release of this open source technology. It comes in just in time for 2020 on Spark's 10-year anniversary. There are a whopping 3,400 community patches that have gone into this release. And there's so many features, I don't have time to truly do it justice during this session, but I'll share a couple highlights. So don't get too excited, I'm not covering everything on this slide. As you know, Apache Spark and Azure Databricks uses a separation of compute and storage. This means that estimating data extraction and arrivals from storage can be unpredictable from a simple query plan at compile time. There can oftentimes be absent or inaccurate data statistics about the data, which leads to misestimated costs at runtime. So we have this new feature in Apache Spark 3.0 called adaptive query execution, which improves performance by changing the plan during runtime as your data is being accessed and processed. It does this via dynamically coalescing shuffle partitions, switching join strategies, and can optimize and parallelize skew joins. The second one on this list, dynamic partition pruning. When you have star schema workloads, you're most likely joining fact and dimension tables. And when doing this, you can filter out many partitions and skip over them when processing your data. In Spark 2.4, this decision has to be made at compile time. And to be safe, it often results in longer scans over the data that you don't need. But in Spark 3.0, as a job is processing, it can adapt and prune that data out of your scans. So TPCDS benchmarks show that this can lead up to 18x performance improvements. So as you could see, we could go on and on for hours about these updates, and really the depth of this content should better be served in a 300 to 500 level depth session. So please go watch the keynotes and sessions from the most recent Spark and AI Summit to get deep into some of these awesome new Apache Spark 3.0 features. Okay, let's move on to Delta Lake and Delta Engine. You know, Delta Lake has been around for about a year now, so I don't need to mention it as a new announcement. But to talk about our new Delta Engine, I want to first call out what Delta Lake is to make sure that no one gets these two similarly named technologies confused. Maybe you haven't heard of Delta Lake yet, and this is the first time you're hearing about Delta Engine. I want to make sure that we touch on both topics here. So first, I know you're here listening because you have data and a lot of it, as we discussed. Your first step in the process is to get this onto a data lake on Azure. And from there, then you create a structured transactional layer with Delta Lake. So Delta Lake can transform your data into a reliable, manageable, high-performant data lake. I'll show you on the next slide how this is possible. Then building on top of that, we have Delta Engine. This is a new low latency query engine. So think about these. You have two building blocks. Delta Lake is at your storage layer. Delta Engine is at your processing layer. And that's how you should perhaps think about them so we don't get them confused as well as we go through. And with these building blocks combined, you are able to leverage these to perform high performance advanced analytics at scale for virtually any use case in any industry. This is really powerful stuff. So let's dive in and talk about Delta Lake. First off, some people can get confused by the name at the beginning and think, hey, do I have to store my data in a new location, Delta Lake? It's not really true. You can keep your data in the same storage of your choosing, Azure Data Lake Storage Gen 2, Blob Storage, whatever it is. And you can think of Delta Lake more as a storage format technology. You can take data from any format, CSV, JSON, Avro, Parquet, etc. Upgrade this to the Delta format with a simple statement like I have on the screen. You can write, you take in your data frame, .write, .format, switch out one word, one keyword there. Instead of saying .format Parquet, switch that out to .format Delta. And when doing so, you get some benefits I'll tell you about right away. When we do this under the hood, we save this data as version Parquet files. We build a transaction log, and we add additional indexes and stats. Let me tell you about some of these benefits. First off, think of the promise of a data lake, the central source of all data, democratized, shared, and accessible by employees across your whole company. Traditional data lakes and Spark offer no concurrency capabilities, but because we have version files and a transaction log, we can promise ACID transactional guarantees that enable simultaneous concurrent reads and writes on all your data. Another problem with traditional data lakes is that things start to get messy. Delta Lake offers various levels of schema enforcement and evolution control, which allow you to set guardrails, but also still be flexible when you need it. You know, when you're in a data lake, you need some flexibility, but you also maybe want to set some guardrails. We offer you efficient upserts with blazing fast and simple merge and insert commands. With version files, you have the ability to travel back in time, reproduce data, or immediately roll back to a prior version of data without reprocessing. You could do this in simple statements that think of like select my data from this table as of a particular timestamp, and you're able to travel back in time and look at data how it was in the past. The next two benefits are uniquely available in Azure Databricks. The first one I'll talk about, let's talk about Z-order first. Everyone probably already knows the basics for Apache Spark partitioning, and you're trying to do this on low cardinality columns. You're trying to do about a gig per partition, but now in addition to this traditional partitioning, you can also Z-order your data on high cardinality columns. This is a technique that co-locates related information into the same sets of files, and it enables this concept of data skipping. So if you think about it, if your data is all ordered in a file by this high cardinality column, and your query engine comes in and you have a where clause or a join statement or whatever it might be, that query engine can then say, all right, I know I can skip all the way through this file to this section of the file because that's what, where your where clause was, or you get really awesome benefits of data skipping with this Z-order command. The other one is called optimize. This command is for file compaction, and it runs in the background to reorganize and compact your data in the perfect size files for high performance Spark compute. If you've used Apache Spark in the past, you probably are aware of the small files problem. You probably already encountered this yourself in real practice, where over time your processing starts to scatter data across many small files. So this optimize command runs in the background, compiles these up to just the right sizes that Apache Spark likes for its high performance processing. Now, we have real customers. I've heard real feedback from customers using these best practices today, squeezing up to 100x faster processing times from their workloads. So there's really some great efficiency gains in your performance improvements here. Okay, with Delta Lake covered, let's dive into Delta Engine, probably one of the most anticipated discussion points for this session. First, I want to discuss the motivation behind developing Delta Engine. This is a serious investment and differentiator for our customers, so I want to highlight why it's important. When developing software, it's important to deeply understand hardware and the trends of where advancements is happening to ensure your software will keep up and capitalize on this innovation. Looking at a few dimensions in hardware trends shows, 10x improvements for networking and storage, but CPU clock speeds have kind of remained the same. But we know CPU clock speeds aren't everything, and CPU performance hasn't been stagnant overall. So where are the latest CPU innovations going? Here on the screen, you can see they have been going into expanding SIMD register width. This allows an instruction to be executed, this same instruction to be executed on multiple data points simultaneously. The other, instruction level parallelism. This allows multiple instructions to be executed at the same time. So to take advantage of this future direction of hardware innovation, instead of just riding the train of improving clock speeds or some of these others, we want to take advantage of these new hardware trends. We need to do a little bit more effort on our end as well, and this is why I want to introduce you to Delta Engine. 2020 is a huge year for Azure Databricks. Not only do we get the incredible benefits of Apache Spark 3.0, but Delta Engine builds on top and extends Spark performance to a whole new level. It is 100% Spark compatible, maintaining easy portability of your code and no lock-ins and everything else that you come to expect when using Azure Databricks. And the Delta Engine is composed of three main components. First, we'll talk about the improved query optimizer. Then we'll talk about the new Delta Engine caching. And coming soon in 2021, we have this new native execution engine that we call Photon. So first, the query optimizer. This extends the functionality already in Spark 3.0 that we briefly talked about with more advanced statistics, and can deliver up to 18x increased performance in star schema workloads. When we go over to the Delta Engine caching layer, this automatically chooses which input data to cache for the user, and it transcodes this data along the way in a more CPU efficient format. And this is the key here. There's always been a lot of caching available in Apache Spark and with Delta Lake and everything else. But here, this caching transcodes this data to take advantage and leverage the increased storage speeds, particularly of NVMe SSDs. By using the combination of hardware with this new caching technology, we have observed up to 5x faster scan performance for virtually all workloads. All right, now with Photon, we have completely rewritten the Spark execution engine in C++ to maximize the performance improvements of modern hardware development across data and instruction level parallelism that we talked about previously. So now that this is written in C++, this means that under the hood, what used to work out your queries and turn them into RDD code and Java bytecode to run in a Java virtual machine, instead of being run in Java, this is run in C++. Think about what this means. Python, R, these don't natively run in a JVM. So there's a lot of overhead bottleneck at the CPU level. The new Delta Engine with Photon is so exciting because it ensures that our Databricks execution engine can break out of these constraints and keep pace with CPU innovations and continue to push performance boundaries for many years to come. Let's talk about impact. We have run a 30 terabyte TPCDS benchmark comparison and have excellent results to share. First, take a look at how using Spark 3.0 in the middle there versus Spark 2.4, this is the vanilla open source Apache Spark versions with no other configurations. This immediately results in a 2x performance improvement. Then if you take that same workload and run it in Azure Databricks with Apache Spark 3.0, this is the DBR Databricks Runtime 7.0, again, immediately another 2x performance improvement. Looking ahead, this same workload running on our Delta Engine with the Photon technology squeezes another 4x improvement versus the Delta engine today. So overall, if you look across the spectrum, this is 20x faster by default than any other Apache Spark service that will be running on vanilla open source Spark 2.4. I know that this chart only talks about performance, but take a step back with me for a second. Realize how this will also impact your cost. If your workloads can now finish 10x faster on the same hardware, you're going to save a lot of money with these performance improvements as well. So I hope you can tell I'm pumped about this new exciting innovation. But let's move on from one big announcement to the next. Let's talk about Workspace 2.0. Workspace 2.0 is a nickname that we use to describe the evolution in our advanced feature set aimed to increase the productivity of data scientists. We have listened to our data scientist customers across many industries, and a common theme we identified and decided to take to the next level is our DevOps workflows for data scientists. There are several different features we have stitched together for our next-gen workspaces, but I want to highlight just one for you today here. We now have a feature called Databricks Projects. This allows data scientists or MLOps engineers to create or clone existing Git repositories on Databricks to carry out their work. You know, if you're already familiar using GitHub, you just go there and click clone and bring that URL in. They can quickly experiment on the latest data and easily access the scalable computing resources they need to get their job done, all while meeting security and compliance in the cloud. So no more do your data scientists have to download sample CSVs onto local laptops or juggle private repos and hosted libraries and do this all on their own hardware or their own setups and be in their own land. This means that exploratory data analysis, modeling experiments, and code reviews can be done in a robust, collaborative, and reproducible way. On the screens, a few screenshots of what this looks like in the project's experience. So you can simply create a new branch, edit your code in open and collaborative notebooks, commit and push changes. This is really exciting for data scientists and all the other personas and roles that work together with data scientists for end-to-end machine learning solutions. All right, let's talk about Redash, a new experience coming to preview soon before the end of this year. The idea with Redash is to make things simple, seamless, and powerful. By talking with customers, we know that you have employees who are SQL powerhouse wizards, but maybe they're not comfortable with Spark and managing clusters and working in multilingual notebooks. For this, we have developed a new collaborative visualization and dashboarding platform designed to enable anyone, regardless of their level of technical sophistication, to develop and share insights within and across teams. We have created a new query editor with improved schema and autocomplete. Users can even drag and drop to create dashboards and to share, and you can schedule refreshes, configure alerts, all of these similar things that you would expect to find. The reason why this is so cool is you're now bringing a whole new workforce to your data lake. Instead of data engineers having to curate, aggregate, simplify data into some kind of SQL packaged environment, you can now enable all of your data analysts to leverage the full power of Apache Spark and the data lake in a SQL-friendly environment. Look forward to this experience coming soon before the end of this year. All right, let's lay it all out. I want to come out to the roadmap and talk about all the things that we've released soon and all the things that are all the things that we've released recently and all the things that are coming soon. So I'm not going to read everything on this slide because there's a lot, but coming off the heels of Redash, let me start by sharing the exciting announcement of the new Azure Databricks connector for Power BI. Previously, when connecting Azure Databricks with Power BI, you had to use a Databricks personal access token. Prepare to put those days behind you, because we now have Azure AD authentication from Power BI and Azure Databricks. This enables Power BI to use your Azure AD credentials to query and visualize your data in Azure Databricks. Even better, this is supported with storage credential pass-through and table ACLs, allowing you to see only the data you are allowed to see based on, table and ACLs or file folder ACLs of underlying storage. This new connector is going to be available this week for Power BI Desktop in public preview. So if you like the thought of giving up on personal access tokens, did you know that we also released the capability to authenticate with our REST APIs using AAD user and service principal backed tokens? With this functionality, you're now able to automate your Azure Databricks deployment end to end. Previously, you had a manual step where you had to obtain a personal access token from the UI before you could launch a cluster. And now those days are no longer. Let me flip over to the next and show you what is coming soon. Coming soon here, I already mentioned that we are on preview on the US government cloud. This will become GA release very soon. We're also going to launch a preview on the Azure China cloud very, very soon, so look forward to that. And if our progress in VNet injection, service tags, IP access lists, these things I know you've been following with Azure Databricks, if these weren't enough for your network isolation requirements, don't worry, we're working on some new functionality to even remove all public IP addresses from your deployment. Our roadmap moves so fast that one of these shipped in between the time my slides locked and this delivery. So we actually just shipped hot off the press what we call customer managed keys encryption of DBFS. When you create an Azure Databricks workspace, we give you a default storage account and call this DBFS, or the Databricks file system. Of course, this storage is already encrypted, but now we're giving you the opportunity to bring your own key to be used for this encryption. Okay, and let me finish it off with my absolute favorite on here. Hopefully it's one of your favorites as well. I know I've heard from many of you that you've been wanting this feature and functionality, Spot VMs. In the very near future, we plan to allow you to create Databricks clusters with Azure Spot VMs. These are super low-cost VMs that are preemptible. What this means is if you have a workload that is not time-sensitive, you would like to save some money, you can choose Spot VMs. We may have to interrupt your job to reclaim, we as in Azure Databricks, as in Microsoft, we may have to interrupt your job to reclaim the VMs for a short period of time, but your job will then resume where it left off and keep moving at a very low cost. So I hope you are inspired by the innovation I have shared with you in this roadmap session. This progress would not be possible without you as a community. So again, I encourage you, please comment, ask questions, reach out to your Microsoft or Databricks representatives, or even find me. My name's Kyle Weller on LinkedIn to share ideas, feedback, or of course, my favorite is hearing about your success stories. So check out these links here on this page for ways that you can learn more or ways that you can jumpstart your journey in leveraging this new amazing technology on Azure. With that, I want to change gears to answer a few questions. I know we're very short on time here, so let me see which one may be the fastest. There is a question that I've heard from many of what are some of the best practices for how to optimize costs with Azure Databricks. So I'll highlight just two with our short amount of time here. First would be leverage our auto scale capability. If you weren't already aware, when you create an Azure Databricks cluster, you are able to tell it to start with a minimum number of nodes in your Spark cluster. And then as your workload demands, we will measure and monitor the utilization of those nodes. And then you can scale that cluster up to a larger size. But the same goes in reverse. As soon as you don't need that compute anymore, that'll scale back down with you. I would recommend checking out auto scaling and also take a difference at the look of our analytics pricing tier versus engineering pricing tier. After you've done some interactive analytics with the data explored, you feel comfortable with the code that you're going to run, convert these to jobs and scheduled jobs. This hits the data engineering pricing tier, which is almost about half. So you get a lot of cost savings there. I think that's about it for me. So Thank you for your attention during this session, and I hope to see you next time.